Hey everyone, my name is Velenin, and in today's video we are going to get a first look at Google Gemini, a new model created by Google that aims to compete with GPT-4. Is it any good? Let's find out. If you want to learn how to create real-world AI applications and deploy them, you can join ML Expert Pro. In it, I'm going to add the new AI Bootcamp, which is going to show you all of those and some basics for machine learning, Python. Then we're going to go through developing an LLM application. I'm going to show you how to fine-tune your own large language model and how to build a RAG system or retrieval augmented generation systems. Then I'm going to show you how you can deploy those systems as well. And finally, we're going to end up with some more advanced topics such as you can see, AI agents, how to create your own dataset, building your own tokenizer, and then a brief review of what transformers are, since they are pretty much the backbone of the modern large language models. So if you want to join in, please go and get the ML Expert Pro subscription. I'm going to add the bootcamp from January 1st. And if you are already a ML Expert Pro member, I'm going to enable the preview of the bootcamp right on Christmas. This is the official blog post that announces Google Gemini, and this is the successor of Palm and Palm 2, which were the previous state-of-the-art models, at least from Google. I would say that those models weren't as good as GPT-4 and Quad, so they're now trying to push these models even further. And you can see right here that this post is actually co-authored by the Google DeepMind CEO, Demis Hassabis, if I'm pronouncing his name correctly. But this is actually the CEO of DeepMind, which is a subsidiary of Google. And the company there is actually working on very advanced AI models. And they were pretty much the guys that were behind AlphaZero. So they have a lot of expertise in building such models and training them. So there is a note from the CEO right here. And then you can go through this blog post. There are a lot of interesting videos that are pretty much aimed at the general public in order to explain what this model is. But one important thing right here is that this model will be actually 3 different models. And actually there are going to be 4, since this final one is going to be 2 different smaller models. But we have this Ultra model, which is going to be essentially the largest one. And yeah, interesting that they chose this name. Then they have the Pro model, which is going to be a mid-range model, and then the Nano model. So this will be essentially a model that you are going to embed on devices, on different devices. And here is the groundbreaking stuff, I would say. This Gemini Ultra is the first model to outperform human experts on massive multitask language model understanding. Essentially, this is a task or a benchmark. So this is a very large achievement. But of course, when you're looking at those evaluations, you need to be a bit skeptical, since these models are, let's say, they can be prompted in different ways. And also those types of models can actually have had a look at the training data. So yeah, it's a bit hard to say whether or not these models are actually performing as well as the authors are claiming. But here is the first thing that they're providing as a comparison between Gemini Ultra, again, the largest and the strongest, let's say, model from the Gemini family, and GPT-4. And one interesting thing right here is that they're probably using here, if I understand this correctly, they're using chain of thought prompting with 32. Interesting what exactly, how are they comparing 5-shot evaluation from GPT-4 with Gemini Ultra. Of course, here different types of prompting might be very might provide very different results. So yeah, it appears to be very interesting why they're doing these comparisons. And you can see that pretty much the model is performing better compared to GPT-4, but on the common sense reasoning for everyday tasks, you can see that GPT-4 is actually blowing off the water Gemini Ultra, which is very interesting as well. And they have some math tasks and then some coding tasks. And you can see right here that Python code generation. This is a zero-shot reported result from GPT-4. I'm not sure if and how they're comparing this, and they have a detailed technical report that we're going to go through. And here again, they're talking about next benchmark, which is essentially this multimodal tasks. So what this means is that instead of just text, we can probably have something like images and let's say more files, audio, etc. So here is the result. So they're comparing this to GPT-4 Vision as the other model. And again, they're taking this multidiscipline college level reasoning problem. And here you can see that Gemini is actually performing better compared to GPT-4 Vision. And this is pretty much the result in all of the tasks. And here on audio task, they're comparing again Whisper V2 and Whisper V3. Then on video, they are comparing with DeepMind Flamingo and Sevilla. Yeah, probably those tasks are compared to other state-of-the-art models. But one interesting thing right here, at least to me, was this document understanding with the Gemini was actually performing quite a bit better compared to GPT-4, since this is a naturally hard task, and those benchmarks are again hard. So yeah, it looks like that this model is performing very well, at least according to the authors. But you can see that the natural image understanding performance is just slightly better compared to GPT-4V. Here, they're talking about their tensor processing units. So essentially, Google are training on their own hardware. They're not using NVIDIA chips. So on these units, they were actually also announcing a new quad TPU, which they're going to name V5P. But this was not actually used, at least according to what I understood from the technical report, for the training of the Ultra and the other Gemini models. This is the technical report by Google DeepMind. And here they state that this family of highly capable multimodal models. And this technical report dives a bit more about how this model was trained and what the training data was and what are the results. And we're going to go through these. Here they have a very nice example of what a prompt might look like. You can combine text and images, and then this is the response that you might get. This is pretty much a standard way to prompt those types of models. And you can see that you can interleave and combine text with images. The model architecture section of the report states that the Gemini models are actually built on top of transformer decoders. So we can assume that this is pretty much standard across the board. And they're optimized for inference on Google Tensor Processing Units. So again, trained on TPUs and then inference on TPUs compared to GPUs. So they're training to support 32K context length. So essentially, this is the context that you can expect from those models. And yeah, compared to what we have from Quad and other models, you can see that they pretty much stuck with 32K of context length. Probably this is enough for most cases. So I would say this is quite all right. And then here is some more details on the nano models. Again, those models are designed to run on devices, so they can be embedded. And you can see the actual number of parameters, 1.8 and 3.25 billion parameters for the two types of models, probably depending on the targeting of the device. And one interesting point here is that those models are going to be 4-bit quantized. So this is something that tells us that quantization is actually going to perform very well on Inference, and they're going to be essentially deploying that to production. Next, it is really interesting that there are actually interleaving text with audio, visual inputs, images, charts, screenshots, etc. So this is very interesting chart. This can be the input sequence. As you can see, you can have, for example, text, some audio, then some video, then some images, and all of these sequences are, or this one sequence is going to be passed throughout their model, which they're simply stating here that is going to be a transformer. And then they have two decoders, image decoder. So this is going to be used for generating the image, if any is going to be generated by this model. And then a text decoder, which is going to essentially generate the text for you. So this is pretty much the overview of the architecture. And yeah, it's pretty nice that they give us at least this amount of details. And we're going to get a bit more details even further. So this is very interesting. The training infrastructure. They're stating here that they was using a TPU v5e and TPU v4, and they were actually training the Ultra model only on v4. So interesting that they didn't use any of the v5 TPUs, and they're saying that this is actually performing, or this is a much higher scale compared to what they used on Palm 2. So again, things are scaling up, and they say that this is proportionately resulted in decrease between failure of hardware in the overall system. So yeah, they're also talking about how are they essentially architecturing the structure of those chips and how are they interconnected and configured. So this is very interesting if you're a hardware engineer or someone who might have to build such large, essentially computational units that can perform such large amounts of training data. And here they're talking about the software. They're using single controller programming model of JAX. So probably they're essentially using JAX in order to generate those models. And I would probably assume that they are writing essentially a lot of custom code in order to run such a large training job. And here they're talking about that they can't actually persist the weights on the cluster storage. It wouldn't be very, it would be actually impossible to do that due to the architecture of their systems. So they're actually using redundant in-memory copies of the module state. I would be very interested in having a look at the code and what they're actually doing and what they do in order to achieve that. Hopefully something like that is going to be outsourced. And they're actually stating that compared to Palm and Palm 2, this provided a substantial speed up in recovery time. So even though the larger training job had to be complete, they're saying that it took a lot less time to recover from crashes. And another interesting point here is that they're talking about failure modes. So essentially what happens during training such large models, some of your hardware may go bad, essentially, and some of the computational units might produce results that are not going to be true or just bad results. Maybe you can compute wrong gradients due to hardware errors, etc. And then during the training, this might corrupt the whole training job. And if this happens, of course, you want to be understand or find it out as early as possible and replace the training units and continue the job as usual. So they're talking about how they were able to isolate incorrect computations and how their infrastructure was actually allowed to do that. So next, they're talking about the training dataset, and this is something that most of the companies are very private about. And here I would say that the training set was not exactly presented to us, but we can go through some of the details. And they're saying that the training set is both multimodal and multilingual, and they're using web documents, books, code, includes images, audio, and video data. Of course, it is really interesting if these documents, etc., is all just public data, or what type of data were they using, since they're just Google and they have a lot of data. And yeah, it would be really interesting to find if this is just public information. So one important point here is that they're using sentence piece tokenizer, and essentially they're training this on a large sample of the entire training corpus. So they're saying that this increases the inferred vocabulary and subsequently improves model performance. So if you train your tokenizer on a large sample of your training corpus, you might get better results. This is the result from that. And they say that Gemini models can efficiently tokenize non-Latin scripts, which can in turn benefit model quality as well training and inference speed. So yeah, essentially they're saying that the models can tokenize, or the tokenizer can tokenize pretty much everything in any language, and this further improves the performance of those models. And here is something really interesting about the training as well. The smaller models are trained for significantly more tokens to improve performance for given inference budget, similar to approach presented before. So interestingly, the smaller models are trained on probably for longer in order to increase their accuracy or performance. We also perform safety filtering to remove harmful content. We filter our evaluation sets from our training corpus. Yeah, it's really hard to try to not leak any of the training data when you're testing your model performance. And yeah, it is a bit hard to do that. So we can't really be sure of any evaluations until we try to play around with the model for ourselves. And here is something that you've probably already know. We find that data quality is critical to a highly performing model. And they were trying to essentially filter out some of the best data to be remained just for training. And then they're talking about the evaluations. And yeah, this is pretty much the same chart that we saw before, except that they now have Gemini Pro with again chain of thought at 8 and 32, probably a context length, not sure about that. And then they're comparing to GPT4, 3.5, Palm 2, and Quote, Grok, and Llama 2. So you can see that, at least according to these benchmarks, pretty much everything Gemini Ultra is beating, except this, actually. I'm not sure what is the distinction here and why we have two rows from this benchmark. Let me know in the comments below if you know what is the difference here. And here you can see that actually GPT-4 is beating Gemini. And another place that we've already saw is on the HeroSwag dataset, common sense multiple choice questions. And you can actually see here that GPT 3.5 is pretty much performing on par with Gemini. And Palm 2 was pretty much better compared to Gemini Pro. Interestingly, they don't have evaluation for Quad 2 right here. Yeah, even Llama 2, which is pretty much a bad performer overall. Not sure which Llama 2 this is, probably the 70 billion parameter model, performs quite well on this dataset compared to Gemini. So yeah, interesting. Oh, these are the chain of thought with K8 or 32 samples. Okay. So these are the explanations via the API November 2023. Yeah, and the authors here state that the evaluation on these benchmarks is challenging and might be affected by data contamination. Yeah, this can be said about all of the models. And again, until we try to play around with these models, we simply don't know how good they are. And these are pretty much the comparisons between the different models. And you can see the increase of the Ultra model compared to the Pro, the Nano 2 and Nano 1 models. Yeah, you can clearly see that the Ultra is performing very well, but the Pro model is performing quite well on some of the tasks compared to the Ultra compared to others. Yeah, so again, they're probably creating good models across the different billion parameters, which we don't actually know the number of the parameters. Here they're comparing Gemini Nano 1 versus 2, multilinguality. Yeah, and here is the final part that we're going to have a look at. How much the sequence position is affecting the performance of this model. And you can see that the Ultra model, on the left, you see negative walk likelihood, which we don't have a number for, which is very interesting. This is similar to something that another company is doing with their charts. I'm not sure why we don't have this here. Is this, what is the scale right here? I'm not sure. But you can see that the sequence position on the x-axis, and you can clearly see that the Ultra model, at least if this is scaled properly, which I'm not sure, since the grid looks kind of strange. Yeah, very, very poor job on this chart. So you can see that the Pro model is actually performing a bit worse compared to the Ultra one. The Gemini models look very promising, but until we get access to the models, we can't be really sure of their real-world performance. Of course, Google has a lot of talent in the name of the Google engineers themselves and the engineers and researchers from Google DeepMind, and of course, a lot of compute power. So probably the mix of all those is going to be a set of models that are outperforming Palm and Palm V2 at least. So what do you think? Are these models going to beat GPT4 and Quote 2.1? Let me know in the comments below. Thanks for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description. And I'm going to see you in the next one. Bye.